Hi everybody, we're going to be starting in section 1.1, discretionary and essential expenses. Alright, so we start with a warm-up here. Let's go ahead and read through it. Once you've read through it, press pause on the video and then go ahead and select your choices or choice. And once you're done selecting your choice or choices, go ahead and unpause it. Alright, so the warm-up asks, which of the following expressions represents the statement 1/2 the sum of x and y. Yeah, so go ahead and look at those three and decide which of those you believe does represent that statement. Okay, so now you should have made your selection by this time. Hopefully you've already paused it and come back to make your selection. If you haven't, go ahead and do that right now. Pause it real quick and then come back. Alright, so looking at the warm-up here, it asks you to take half of a number. Well, the only way to take half of a number is if you know what the number is to start with. What are you taking half of? In this case, you're taking half of the sum of two numbers. So there's this expression, the sum of x and y. Well, sum means to add, right? So sum of x and y means x plus y. So if you were looking at your three choices, all of them have x plus y in some version or another, right? What you're asked to do here is to do the sum of x and y, so it needs to have x plus y, all three of them have it, and then you take half of that. So to take half of a number, you can just multiply it by 1/2. So B is definitely an answer, right? It's half of that sum, x and x plus y. Alright, well, multiplying by 1/2 is the exact same as multiplying by 0.5. Alright, they're just two different versions of the same number. One's decimal, one's fraction. Now, multiplying by 1/2 is the same as dividing by 2. Dividing by a number and multiplying by its reciprocal are the same thing. So dividing by 2 is the exact same as multiplying by 1/2. So actually, in this case, all three of those are your answers. Notice, nowhere in there did it say there was only one correct answer. Alright, so let's go ahead and move along here. Alright, as in most units, we will begin with some basic vocabulary. Alright, and since this section is dealing with discretionary and essential expenses, we are going to start looking at some of that. So, whether an expense, that's money that you spend out of your paycheck, out of your earnings, right, is discretionary or essential, basically where it comes from as far as your income is concerned does play a role into that, especially the discretionary income portion. So let's talk about the income first and then get into your expenses, because you have to have the income before you get to the expenses, right? You have to make money before you can spend it. Alright, gross income. Alright, so your gross income is the income that you have before paying your taxes. It's what's on your check before you pay any taxes or have any deductions removed from your income. Alright, now, out of that gross income, you know, they take out taxes and all sorts of other things, but what's left over is your disposable income. It's money that you have to dispose of how you choose. Alright, so that's considered disposable income, and because it's income you can dispose of, you know, in whichever manner you'd like. Alright, let's now talk about some expenses. Essential expenses. What are those? An essential expense is an expense that's necessary, right, and you cannot eliminate it. So, you know, this might be something like your rent or your grocery bill, right? You've got to have shelter, you've got to have food, right? Those are essential expenses. You can't eliminate those. Now, you can pare them down, right? You could maybe find a cheaper place to live, or you could, you know, buy top ramen for the rest of your life, right? You can cut down your expenses, but you can't eliminate them. Those expenses are essential. All right, the next one down is discretionary expenses. Discretionary expenses are expenses that are non-essential. It's kind of the opposite right here. It's you are deciding whether you want to make that expense, whether you actually want to spend that money or not. So this might be going to the movies, or maybe buying a new tablet. Okay, let's look at data. A lot of this first chapter, really most of the mathematics that kind of go along with the finance you learn in this chapter, really is all about data and statistics. So let's talk about what those are. All right, data. Data are just facts that are gathered and studied. All right, now typically this tends to be numerical facts, numerical values that are gathered and then studied and analyzed, that sort of thing. Not always, though. Data can be, words and things, but as far as our class is concerned, the data that we're going to be looking at collecting and then analyzing, we're going to be looking at numbers in this class, obviously, being a math class. All right, statistics. Statistics is a branch of mathematics that deals with collecting, organizing, studying, interpreting, analyzing, and reporting that data. Okay. All right, moving along here. The next term in our vocabulary here are measures of central tendency. So what happens is you collect all this data, and you want the data to make some sense, right? You look at this data, and sometimes you have an overwhelming amount of data, sometimes not so much data, but either way, you want that data to tell a story. You want it to have some meaning. All right, and one of the stories that you can get out of your data is, where is the center of your data located? Where's the middle, right? You might have data, numbers ranging from very small numbers to very large numbers. Where is the middle of that data? That's a pretty important thing to know. All right, so that's actually what measures of central tendency are. They're ways of finding, the middle, the center, which is why they're called central tendency, right? How do the numbers in your data tend toward the center? All right, so what's the typical value in a data set? All right, now there's three main measures of central tendency, and you all have learned about these for years, probably starting way back in elementary school. They're the mean, the median, and the mode. All right, so we're going to start this easy. You guys have learned about mean, median, and mode before. So let's get that first one out of the way. The mean is the average. All right. So some teachers in elementary school start to teach it to you originally as the average, and then probably somewhere along the way you heard that there's another word for average, and it's mean. So those are two synonymous terms. Mean, average mean the same thing. And basically the way you get the mean, the average, is you take all your data values, you add them together, so that means you find the sum, and then you divide by how many data values you have. So you count how many pieces of data you have, and then you take your sum and divide by that number. That's your mean. The median is the one in the geographic center, the one that's right in the middle of all the other numbers. So, if you had three numbers, three data values, your median would be the second one. It's right in the middle. Right? It's kind of the Goldilocks, not too low, not too high, just right in the middle. That's your median. All right, the mode. The mode is the most frequent. It's the one that shows up the most. Right, and so those are your three measures of central tendency. Now, the way sometimes having these little memory tricks can help you in learning some of this vocabulary. I know when I was first learning mean, median, and mode, I had an elementary school teacher who said, "Hey, the way to remember mean is the average teacher is mean." Not me, of course. I'm wonderful and perfectly pleasant, but the average teacher is mean, right? So think average and mean go together. All right, the next one, median. Kind of sounds like medium, right? If the water was, you turned on the faucet and the water was medium, it's not too hot, it's not too cold, it's kind of right in the middle, right? Another way to think about that, a lot of you have your license and drive, right? The median is that thing right in the middle of the freeway. So median actually means middle. All right, and mode. The first two letters in the word are mode, right? And the first two letters in the word most are M-O, and the first two letters are M-O in mode. So those kind of go together, mode and most. All right, so those are maybe just some little mnemonic devices to help you remember those, which one is which, mean, median, and mode. All right, let's look at that next vocabulary item, skewed data set. Skewed data. When your data is skewed, it means the mean and the median don't equal each other. All right, and oftentimes this happens by having extreme values. Right, extreme on either on the far left, lower than the median, or mean, or numbers on the far right of the median. So kind of extreme values tend to lead to skewed data. All right, outlier. What is an outlier? An outlier is a value that is extremely different than the other values in a data set. All right, and there's actually a mathematical way of calculating if something is an outlier or not. But for now, let's just think of outliers are data values that are kind of way out of whack compared to all the other ones. They're much, much higher or much, much lower than all the other data values. All right, moving along. Let's look at our first example. We're going to look at finding the mean, the median, and the mode of some data values here. All right, so our example says your cell phone bills are as follows. All right, so you've got some cell phone bill data there, right? It looks like some data values, and it's asking us to find the mean, the median, and the mode. All right, so the mean is the average. Now, the way you find your average, like I said in the previous slide, was you find any average, any mean. You take all your data, in this case all those numbers, and add them together, find the sum, and then divide by the number of data values you have. So if you count these, you have, looks like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 data values. Now, mathematically, we would say that that means our n is 10. The n is the number of data values, and that's why there's the letter n. All right, so to find the mean, what we want to do is we want to add all 10 data values and then divide by 10. All right, so that's how we're going to get the mean. That's pretty easy to do. I'm sure most of you remember how to do that. All right, the second question is asking us to find the median. Now, the median can be a little bit trickier than you might think. Remember, the median is our geographic center. It's the number that's right directly in the middle of all the numbers. So since we have 10 data values, the median is going to be right in the middle of those 10. So there should be kind of 5 on the left and 5 on the right, right? If there were 10 people standing in a line, I told you to go stand right in the middle of them. You'd stand so that 5 people were on your left and 5 people were on your right. So the same thing here. Finding the median, there's going to be kind of a geographic center right in the middle of them. But one of the things that makes finding the median tricky is you cannot, and you really need to be careful on this, you cannot find a median until you have your data ordered from smallest to largest, from the minimum data value to the maximum data value, smallest to largest. So since we're going to need to do that here in this problem where we are finding the median, to find the median you have to reorder these from smallest to largest. Notice the first term is 89, the very next term is 77. It's smaller, right? Obviously that's not going from smallest to largest. So let's go ahead and reorder this real quick before we do anything else. Alright, so looking at all 10 values, it looks like the smallest data value is this one, 74. Alright, so I'm going to rewrite it. I'm going to put 74 on the left, since that's my minimum data value. Alright, now I'm just going to go in increasing order, right? Ascending order, from smallest to largest. So the next biggest one is 77. So let's put that next. The next biggest one after that is 82. So let's put that in. Now you'll notice as I'm doing this, I'm crossing them off my original list. Now I like to do this because if I cross them off as I rewrite them, I won't count the same number twice, or I won't forget to count a number. All right. So after 82, the next biggest value is 84. So let's rewrite that in order. After 84, the next biggest one is over here. It's 89. Now over here, there's actually another 89. So let's take that 89 and put it in order. And after that 89, the next biggest one is 90. Let's put that up there. And then after 90, it looks like our next biggest one is 92. After 92, the next biggest one is 93. And then after 93, the only one left here is 95, right? So I now have my data values reordered from smallest minimum to the largest maximum, from 74 to 95, all right? I must do this in order to find the median, all right? And then the median will just be the middle value right there. All right, the final thing that we're asked to do is to find the mode. And to find a mode, you just find the one that shows up the most, that's the most frequent, okay? So let's go ahead and attack these problems. Let's find the mean. So the way we find our mean is it's an average, right? So we find the sum of all the numbers, and then we divide by n, the number of values. All right, so if I were to add 74, 77, 82, 84, blah, 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 all the way out to 95, if I were to add all 10 of those data values, they actually add up to 865. So that's the sum of all 10 numbers. And now you divide by n, and remember, n is the number of data values, which we had was 10. So if we take 86.5 and we divide by 10, we get, or 865 divided by 10, we get 86.5. So that is our mean. All right, let's look at the next one now. Looking at the median. The median is the one in the middle. Okay. Now, looking back to that example I gave you a minute ago, I said, hey, if you saw 10 people lined up in front of you, and I told you to go stand in the middle, you would go stand in a position where you had 5 people on the left and you had 5 people on the right, right? Meaning you would be the one in the middle, right? You would be the middle data value, but you would actually be the 11th person if you were to do that, right? You'd be the 11th person in line. So when there's 11 people in a line, there is one person standing in the middle. But if you think before that, before you went and stood in that line, there were only 10 people in the line. And if there's only 10 people in line, there really isn't any one person in the middle. So look at these data values, 74, 77, 82, 84, 89, 89, 90, 92, 93, 95. There's 10 of them. There isn't any one in the middle. The middle is actually right here. All right? Look at that line that I just drew in there. There's 5 values on the left. There's 5 values on the right. That line is actually right in the middle. So that happens sometimes, and it actually happens half the time. Right? Anytime there is an odd number of data values, there's going to be one data value right in the middle. Anytime there's an even number of data values, like in this case, there are 10 data values. Anytime your n is an even number, there isn't one middle data value. There's actually 2 middle data values. So the middle data value, there isn't one, there's actually 2 of them. Both of these are the middle data values. So what you do in that case, when there's 2 middle data values, is you average them. You take the mean of these. So if I were to take 89 plus 89, right, add them, and then divide by 2, that's how you find an average, right? Find the sum, add them, and then divide by how many there are. There's 2 in the middle. All right, what I'm going to get is 178 divided by 2, which is still just 89. This should make logical sense to you, right? The average of 89 and 89 has to be 89, right? All right, final one here. Let's look at the mode. The mode is the one that shows up the most frequently, and all of these data values only show up once, with one exception, the 89, right? 89 shows up twice, right? So that is our mode here. Our mode is 89. That's the only one that shows up more than once. Now be careful, mode does not mean it shows up more than once. Mode means it shows up the most, right? In this case, 89 shows up more times than any other data value, so that's the mode. Alright. Let's look at example number 2 here. Now, example number 2, you'll notice it's still kind of the same problem, right? You still have your cell phone bill. There's still 10 data values. It's actually the exact same data values from the last example. But I'm asking you to do different things now with this data. You'll actually find that to be the case in this class. You really have to get in the habit of really being very careful when you read the problem so that you know exactly what you're being asked to do. Right? There's a lot of word problems in this class, and you can't just scan the problem and think you know what it's going to ask you. All right? I gave you these 10 data values in the last problem, and I asked you to do 3 different things. I gave you the same 10 data values in this problem, and I'm asking you to do 3 totally different things. So it's 6 different problems all using the same data. So you really need to make sure you're reading the problem so you know what you're being asked to do. All right, and read very carefully. This first, in example 2, the first part of it asks you to find the sum of the first 3 values. So it's asking you to find a sum. Well, we know sum means to add, right? And so we're looking to add some things. Well, what are we looking to add? It said find the sum of the first 3 values. All right, well, the first 3 values are 89, 77, and 92. All right, now to find the sum of those, I need to add those 3 numbers together. All right, and adding those 3 numbers together gives me 258. That's the sum of the first 3 values. Alright, part B asks us to find the mean. Alright, so we're doing something different now. We're not finding the sum, now we're finding the mean. And remember, mean means that we are going to add, find the sum, and then divide by n, the number of values. Alright, so we need to find the sum of the middle 4 values. Well, the 4 values in the middle are these guys right here. Right? Those are the 4 middle values. Notice there's 4 in those brackets. There's 3 on the left, 3 on the right. That means those 4 in the middle, those 4 that I have in the bracket must be in the middle. Alright, so I need to find the sum of those. That means I'm going to add them together. So I'm adding 84 plus 89 plus 95 plus 82 and divide by n. So how many numbers did I add together? 4. Alright, so when I do that, I end up getting 350 divided by 4, which ends up being 87.5. Then I'll go ahead and erase here. Sausage fingers got in the way. Sorry about that. Alright, let's look at the last one. Once again, we're finding a mean, but now we're finding the mean of the last 3 values. So now, instead of finding the mean of the middle 4, now we're finding the mean of the final 3. So these 3 values right there. Alright, so once again, we know the mean means find the sum. So we're adding and dividing by the number of values. Find the sum. So we're finding the sum of the last 3 values. So 90 plus 74 plus 93 divided by the number of values we added, which was 3. Right. And that gives us 257 divided by 3, which is 85.66 repeating, so I'm just going to write 85.6 with a little bar above it. So 85.6. Alright. So, now let's talk about sigma notation. Sigma notation is another way of saying summation notation. You're summing, you're adding some numbers together. All right, and so that thing that you see, that big black weird shape right in the middle of your screen, that is the Greek letter sigma. All right, and sigma, anytime you see that, it means you're going to be adding some stuff together. All right, so it's just kind of replaces the word sum. All right, and in the last problem, we were doing things like finding the sum of the first 3 terms, finding the sum of the middle 4 terms, finding the sum of the final 3 terms, right? And that took a lot of writing, right? I had to write out, find the sum of the middle 4 terms of the following sequence of numbers, or the data, blah, blah, blah. Mathematicians don't like to write. We don't like to write a bunch of words and sentences unless we absolutely have to. So mathematicians for a long time now, instead of writing find the sum of the middle 4 numbers, they just write something like what you see there in black in the middle of the screen. It's kind of a shorthand way of saying, hey, you're going to add some stuff together. All right. So that Greek letter right there, that kind of E-looking letter is sigma. That means add some stuff. All right. So now, if you're just adding a bunch of data values together, you'll always see xi right there. And that means, hey, you're just adding all your x's together. Okay? I'll explain the I here in just a second, but if you're just kind of adding a bunch of random data together, you'll just see that as an xi. In other courses, in other, levels of math, even some examples that we may get to later, sometimes you'll see an algebraic expression in there. And that just kind of tells you how to find the numbers in the list if there's some sort of pattern. Okay. In our case, there wasn't any pattern to our cell phone bill. It was just kind of random numbers, so that's why you saw the xi. If there was a pattern, such as the bill went up by $5 each month, you might see an algebraic expression there where it tells you how to find what your bill is every month. Okay. Now let's look at the things that you see on the top and bottom of the sigma. All right, at the bottom is your starting point. So that's kind of where what value are you going to start counting on? Okay. So in this case, you see I equals 1. That means you're going to start counting, you're going to start adding, you're going to start summing at the first term in your data. Okay. If this had been I equals 2, that means you would disregard the first term. You would not count it in the sum. You would only start counting the sum from the second term on. If this said I equals 7, you would start counting the sum at the 7th term, and you would ignore the first 6 terms. All right. So this is like your starting point. What number are you going to? What data value are you going to start taking your sum at? All right. Now the top number is your stopping point. Now you see right now it says n, because this is just a general form. But if I actually ask you to find a sum, I would put a number in there up top where the n is, and say like 10. Okay, so if it said I equals 1 on the bottom, that's your lower limit, and it said 10 on the top, that's your upper limit, that would mean I would want you to add the first through the 10th terms. Okay? Alright, so you'll understand this probably a little bit better once you start seeing some examples. It's kind of a weird looking notation, but it's just real quick and easy to write and conveys a lot of information packed into a little tight ball of writing right there in the middle. Alright. Okay, so why are we talking about this sigma notation? Alright, well, sigma means sum. You're going to be adding some stuff. And I think back to what we did really right at the beginning of this section. We were talking about averages, means. Well, how do you find a mean? Well, the way you find a mean, right, is you take the sum and you divide by the number of data values you have. Alright, so This, what I have written on the right that I just hand wrote, is how we say it in words. The way you find a mean, the mean is equal to the sum of data values divided by the number of data values. All right? Now on the left, kind of in the middle of the screen in black there, what you see is you see this X with a little vertical line segment above it. That's called X bar. And in statistics, anytime you see an X with a bar above it, it means average. It means a sample mean. You're finding a sample average. Okay? So that's what the X bar means. So in this case, this is saying your mean equals. All right. Now let's look at this part that has the red dotted line around it. The part with the red dotted line around it, the thing that's circled in red there, that is exactly what was on the last screen. That is the sum. Okay? Now, so this part, X bar, means the mean equals 1 over n times the sum. Okay? Well, remember what we did on the warm-up. When you divide by a number, it's the same as multiplying by the reciprocal. So dividing by n is the same as multiplying by 1 over n. So this is the exact same as this, right? Dividing by n, multiplying by 1 over n, they're the same thing. Okay? And mean is X bar. Here's your 1 over n right below it. Sum, this whole thing means sum. Okay, so these three formulas all mean the exact same thing. It's telling you how to find a mean. It's just in words, and then, in words with, instead of dividing by n, multiplying by the reciprocal. And then there's how to find the mean using statistical nomenclature, naming system, X bar instead of mean. Alright, a little bit more vocabulary here to go. Alright, let's talk about, we talked about mode. Remember, mode is data values that show up the most. Alright, now when we did our example before, there was one mode, the number 89 showed up twice. That would be considered unimodal. Una, think about that prefix uni, means one, right? Or all, right? So the unimodal, there's one mode in your data. All right. The next next vocabulary item is bimodal. Think about that prefix bi, bicycle, that kind of thing. Means two. All right. So bimodal is data value with two modes. Sometimes data can have two or even more modes than that. Let's say there's some data where think about months, days of the year in each month, right? It's 31 or 30, February's 28, right? And so some months have 31, some months have 30, right? And I think the most amount of times, number of days in a month shows up is 31, right? So that's unimodal. Now, if there was an equal number of days that had 31 days and 30 days, let's say that there were, 5 months that had 31 days, 5 months that had 30 days, then you would have 2 modes, right? 2 most often. So that would be bimodal. All right, frequency distribution. Frequency distribution is we're going to see an example of this here in a minute. It's a table that just a lot of times is used when there's a lot of data. It helps you to make sense of kind of an overwhelming amount of data. You can really look right at it and gather a lot of important information without having to look at this huge long list of numbers. Huge long lists of numbers are hard to get any meaning from. Frequency distributions help to give you meaning out of a bunch of data. All right, so that's that. All right, so speaking of long lists of data, let's look at this example. Example 3. It says a section of students sitting in the red wave is asked their age at the first home football game. The responses are as follows. So all those numbers you see, they basically went into the red wave and just started asking people, how old are you? Right? And there are the ages. Now, I gave the data to you here in ascending order, from the smallest to the largest. But even after ordering the data from smallest to largest, it's still kind of an overwhelming amount of data to look at right there, right? Like you look at all those and all the numbers start blending together, and it's kind of hard to see what's going on, right? It's just a bunch of seemingly, maybe not random numbers because they are ordered, but just an overwhelming amount of data there. You know, how do you look at that and go, well, what's the mean, the median, the mode? That's tough to see right there, isn't it? All right, so rather than having the data displayed this way, oftentimes when you see an overwhelming amount of data like this, you will see a frequency distribution, sometimes known as a frequency table, being used to display this exact same information, but to display it in a way that's much easier to handle and much easier to get some useful information out of, right? So here's what a frequency distribution looks like, right? You take your data values, in this case our data values range from 13 to 19, and you list them out here in the left column. So you'll see the left column is labeled age, and it goes from 13 to 19. And at the bottom you see total. It doesn't really make any sense for us to total these ages. It doesn't do anything for us. And we are going to total the other columns, and you'll see what I mean in a minute. Alright, so the next column over is labeled frequency, F for short. The frequency is how often something shows up. What is the frequency of a number means what is how often does that number show up? Okay, so here the frequency. Let's look at age 13. Look at our list of data. There are 3 people in the red wave with age 13. I guess that means the seniors are losing their touch. They didn't kick the freshmen out of the red wave right there, right? 3 little freshmen snuck into the red wave. There's 3 of them. So that's our frequency. Our frequency is 3. There are 3 people at age 13. All right, now let's look at the 14-year-olds. How many of them are there? Well, there's all these 14-year-olds here. It looks to me like there's 8 of them. All right, now let's look at the 15-year-olds. There's these ones here. But that's not all. There's also these 3 down here. All right, so in total, how many 15-year-olds are there? There are 14 15-year-olds. All right, now let's look at, oops, I forgot to count this guy. There we go. There's 14 15-year-olds. All right, now let's look at the 16-year-olds. There are that many 16-year-olds. All right, count those up. It looks like 16 of them. All right, now let's look at the 17-year-olds. There's 1, and then all of these guys down here. A lot of the 17-year-olds. If you count all those, it looks like there are 16 of them. All right, now let's look at the 18-year-olds. There are these 6 up here, and then there are those 6 down there. So there's a total of 12 18-year-olds. And then there's one, I don't know, maybe super senior, or maybe somebody who came back to visit, but there's one 19-year-old. All right, so that's what a frequency is. Now, one of the nice things about a frequency table here is that I can very easily add all these numbers up, right? Like 3 plus 8 is 11, 11 plus 14 is 25, 25 plus 16 is 41, 41 plus 16 is 57, 57 plus 12 is 69, 69 plus 1 is 70. I can do that easily in my head very quickly. That is a lot easier than counting these, going 1, 2, 3, 4, 5, right? If you count all the way to 70, chances are you're probably going to forget where you are somewhere and count the same number twice or skip a number or something like that, right? So frequency table makes it very easy to see your N. What is your total number of data values? Okay? So that's just one of the many useful things that a frequency distribution does for us. All right. Now, you might not see why I'm going to do this just yet. On the next slide, it'll probably become pretty obvious why we're going to do this. But the next column over says product. So let's look at the product. When you have a frequency table, you're pretty much always also going to have a product column somewhere. In a product, just like we've been talking about a sum means to add, product means to multiply. So we're going to multiply the age, 13, times the frequency, 3. Okay? And we're going to multiply those and get 39. Alright? Now why did I just do that? What I really did was I have just now found the total age of all the 13-year-olds. Because remember, there were 3 13-year-olds. If I added 13 plus 13 plus 13, I would get 39. Okay? So, 13 plus 13 plus 13, that's pretty easy to do in your head, 39. Okay? But let's do this next one, 14 times 8. 14 times 8 is 112. Okay? So what did I do right there? I found the total age of all these 14-year-olds. If I did 14 plus 14 plus 14 plus 14, blah, 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 8 times, I would get 112. So, I don't know about you, but I would much rather multiply 14 times 8 than to add 14 plus 14 plus 14 plus 14 8 times. Alright, so let's finalize all this. 15 times 14, that gives us 210. 16 times 16, that's the perfect square, that's 256. Just that. Alright, 17 times 16 is 272. There. Alright, 18 times 12 is 216. And 19 times 1 obviously is 19. Alright, now adding all those together, let's add all that together, you get 1,124. Okay, now that number is going to become important on the next slide. And I'll show you why we did this final column. I'll show you why we did that on the next slide. Okay? But a frequency distribution has now been done for us. Basically, we're just showing how often a data value shows up, and then you take your data value, in this case it's your age, and you multiply by the frequency, and it gives you the total amount of data for that particular data category, in this case 13-year-olds. Okay. Alright, so why did we do this? You'll notice now I have that exact same table, but I have it nice and neat without my sloppy writing. Alright, it's typed in there. Alright, it's asking us to find the mean. Okay, well, let's go back a slide. If I asked you to find the mean when you, before you sat down to look at this, you would probably look at this overwhelming amount of numbers, 70 different numbers, and go like, oh my gosh, I don't want to add those. And I wouldn't blame you. I wouldn't want to add those together either. Remember, finding a mean means you gotta find the sum and then divide by n, the number of data values. Okay? That's how you find a sum, or a mean, is you take the sum and you divide by n. Well, we have the sum right there. We added all our data values already. Remember, this was the total 13-year-olds, this was the total of 14-year-olds, the total age of the 15-year-olds. So the total age of everybody, that's the sum, which would be the same thing you would get if you were to add all of these numbers, is 1,124. And it was nice and easy to find in the frequency distribution table. It was not nice and easy to find in this big, nasty list of numbers. Okay? So our sum is 1,124. Then divide by n. Well, we have our n. It's right there. Okay? 70. Okay, so if I take that, 1124, and I divide by 70, I get 16.057, or approximately 16. Alright, now the median's a little bit tricky. Let's look back to the way the data was originally given to us in this list. Probably a little bit tricky to find where the middle of the numbers are in that big list, right? That would be a little bit tricky. It would probably be easier if it had all 70. Imagine the same bit of data here. Instead of written in 1, 2, 3, 4 rows, instead it's written as one long, just numbers 1 through 70 in one long row. So imagine 70 people lined up in front of you. Okay? Isn't it true that the middle of those 70 people, you're going to have 35 in one group and 35 in the other group, right? The middle of 70, you have 35 on the left, 35 on the right. Okay? So the middle is right in between the 35th and 36th person. Remember what we talked about earlier. When there's an even number of data, in this case there's 70 people, there's actually going to be two middle values. So the two middle values, there's the first 35 people and the last 35 people. So the two middle values are going to be the 35th and 36th person. All right? So you could go through and count until you get in this list to the 35th and 36th person. But there might be a little bit easier way in the frequency distribution. Okay? Let's look at the frequency. We know there are 3 13-year-olds, and then there's 8 more 14-year-olds. So far there's a running total of 11 people. Okay? Now there's 14 more people that are 15 years old. So far that's 25 people. We have not made it to the middle. Remember, the middle is between 35 and 36. Now, once we add the 16-year-olds, there's 16 more people. Now that's a total of 41. Alright, so the 13, 14, and 15-year-olds only take us to 25, the first 25 people. The next 16 people, which by the way is the 35th and 36th person, are age 16. So that is our median. Remember, you're going to average the 35th and 36th person. Well, since they're both 16, your median is 16. Alright, mode. Mode is the one that shows up the most frequently. Alright, well, the most frequent data, right, 13-year-olds, there's only 3 of them, right? Not many, daring freshmen coming into the red wave, right? The most number of people are either 16 years old or 17 years old, right? There are 16 16-year-olds and 16 17-year-olds, right? So your mode is right there, right? Your mode is also 16. Oops. 16 and 17. Alright, in this case, the 16-year-olds and the 17-year-olds show up an equal number of times. There's an equal frequency. There's 16 of each age group. Alright, so the mode is actually 16 and 17, meaning it is bimodal. And there are 2 modes. And that concludes the notes for section 1.1. Hope you like it.